Hello and welcome there. This report about logic gates. Presentation by زهراء محمد عبد الستار and supervised by Mr. Ahmed Settar Al-Husseini. At first, we should have general knowledge about logic design and logic gates. So we have the introduction about it. Let's see what intro say. Introduction. Logic design, basic organization of the circuitry of a digital computer. All digital computers are based on a two-valued logic system, 1 or 0, 1 or off, yes or no. Computer perform calculation using components called logic gates, which are made up of integrated circuits that receive an input signal, process it, and change it into an output. So, what the definition of logic gates? We can say logic gate, it is a physical device which performs logic operation on one or more logical inputs and produce a single logical output. The most question we thinking about when we study the logic gates, we say what is function and how it was work. We say by connecting logic gate together, a device can be constructed that can perform basic arithmetic function. In here we have the symbols of logic gates and the type of it. Type of logic gates. So here we are having 3 basic gates and 2 universal gates and 2 special gates. In the basic gates we have the and or and not gates. In the universal gate we have NAND and NOR. In the special gate we have XOR and XNOR. The NAND and NOR gates are called universal gate. We say why they are called that. Because by using NAND and NOR we can implement all other gates. So total we are having 7 gates. Now we will see the truth table, logic symbols and the functionality of every gate here. Now we start with AND gates. It has an input. N was greater or equal to and has 1 output. AND gate has a multiplication. We say the symbols of AND gate. We say they have 2 input and can be more and just 1 output. When we see the truth table, we found all the output was show all output value of 0, except one cells have the value of 1. By the truth table of and just when we put the value of 1 in the cell of A and B, it was the output was 1. Other they have 0. And another ways we can see, we can use the multiplication, such as we say 0 multiplication 0, it was 0. 0 multiplication 1, 0. 1, 0, 0. Just when we say 1 multiplication 1, it's make 1. Another gate, we have the OR gate. It has an input. N was greater or equal to and 1 output as usual. The OR has the symbols 2 input and just 1 output. Truth table was, in the truth table all output show a value of 1 and just 1 cells have a value of 0. So when we put in the cell of A and B 0 in the both of cells, the output was 0. Or by using the other way, by using the operation of the OR gate, it was a summation. When we say 0 plus 0, the result was 0. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1, 1. So we can use the both of these ways. We go to the NOT gate. NOT gate is also known as inverter. It has 1 input A and 1 output Y. For example, the symbols of NOT gate and this the truth table. It has just 2 input and the 1 output. When we make 0 in here, the result was 1. Just invert. When we put 1, the output was 0. So the NOT gate, it was just make invert to the value. Then we go to the inverse gate. We start to the NAND gate. So here we can say NAND is equal to AND plus NOT. Operation is known as NAND operation. It has n input, n greater or equal to and 1 output. The symbols of NAND gate was AND, symbols of AND symbols of NOT. Together make the NAND gate. And this is the truth table of it. In here we have 2 operating to make on this value. The operating of AND gates and the operating of NOT gates. And was multiplication and not just make invert. So we say 0 multiplication of 0, it was just 0, and what the invert of it, it was 1. We choose that 1 multiplication of 1 was 1, and then they go to the NOT gate. It make invert and it was the output was 0. So we go to the second gate of the inverse. It was Xnor Gate. A NOT gate has a NOT gate plus OR gate operations is known as Xnor Operation. It has n input, n greater or equal to and 1 output. The symbols of NOR gate, the OR gate and the NOT gate together make these symbols. 2 inputs and 1 output. The truth table show the outputs all have value of 0 except 1 cells. When we are input to 0 in the both of cells, the output was 1. In this gate we have 2 operating such as NAND gate. But the difference between that, the NOR gate have our operating and it was the summation. And the same NOT gate, they have just invert. We have this, for example, we put 0 and 0, we say 0 plus 0, and the result was 0. Invert was 1. The last one, we say 1 plus 1 to make 1, and the invert was 0. Then we get the special gate. Xnor Gate is a special type of gate. It can be used in the half adder and full adder. It has an input n greater or equal to and have one output. The symbols of Xnor Gate was have 2 input and 1 output. When we say the truth table, we found the similar inputs have the value of 1, such as 0 and 0 have 1, 1 and 1 have 1, and the different inputs such as 0, 1 and 1, 0 have the 0 value. Now we have some note to find the output of logical statement. We must follow the steps below. 1. If you find the practiced, the operations inside are executed first. 2. Logical gates note. 3. Logical gate and. 4. Logical gate or. If equilibratory, it is executed from left to right. Example, we have example to do. We are saying in this table have x and y and z, and the operation was x and z, this one operation, and the two operation was the x and z, all of them, or y. We have this number 1 0 0 make 0, 0 and 1 make and 1 and 1 make 1, 0 and 0 and 0 make 0. What's this? We can find this by two ways. One way was by operating of gates. When we see x and z, the and was the multiplication or was the summation. We say x multiplication z plus y. What's make? We have the first cells 1 0 and 0. We say 1 multiplication 0, the result was 0 plus 0, it was 0. True. The other ways was by make a little table to remember as the table of the and the or. We say in here we put the 1 that have 0. What's the between x and z? The and between x and z make 0. Then we have the 0 and the y have the 0 in the operating or, this make 0. When we return to example, maybe the students say why you are with the 0 and 1 in the same place. We just need to choose one of them. Why there two? I say when you put 0 or 1, the both of this value it was true. How? Let's check that. When we saw the first ways, we see the x multiplication z plus y. We choose the first number. We put in the input 0 multiplication 1 plus 1, it was 1. And we choose 1. 1 multiplication 1, result 1. Plus 1 to make 1. So the both of them was true. In the second way, we choose in the x 0 and 1, the z 1 and 1. 0 and 1 make the AND 0. 1 and 1 make 1. Then they make operating with OR. 1 and 1 make 1. 0 and 1 make 1. So it is the same result for the both of values 0 and 1. Now we are arrived to the end of the report. Thank you for your attention and watching. Have a good time.